Okay guys, this video is the first one of few videos on debugging and assembly code in MPLABX IDE. For that, here I use MPLABX IDE version 5.15. First we will log into this small code that I have written for the purpose of debugging. Now here in this code we can see in the beginning we have written the include file for PIC16F 877A. So this includes all the hardware definitions such as addresses for these particular labels given. Now at the beginning of this code it asks the program to jump to the label start. So label start is right here at line number 12. So when it comes to the line number 12, so it will execute this first line in line number 13, that is BSF status comma RP0. What does this mean? This one is bit set F status register and RP0. This means set the RP0 bit of the status register. So with that we are moving on to the register bank 1. So this code is trying to now access the register bank 1. So in the register bank 1 it asks us to clear trace B register and clear trace D register. So what does this mean? Trace registers are for data direction. So we are making data direction register of port B and port D to all zeros. That means setting all the bits to output. Now in port B and port D all the pins are set as output pins, and then it says BSF trace B comma 0. That means bit set F in trace B register bit 0. So in trace B, that means port B register, the 0th bit is set as input. When trace bit is 1, that means that is set as input. So in port B register the 0th pin is set as input. Now in port D register all the pins are output. In port B pin 1 to 7 are output and pin 0 is input. Now it says BCF status RP0. This means bit clear F, the RP0 bit of status register. So now this is trying to access register bank 1 again. So it says CLRF port B. That means it is clearing the port B. That means all the pins of port B is set to 0, and then bit set F port B 1. That means bit set F, the first bit of port B register. Now this means the first bit of port B register is set. That means that is set to high. Now then it will go into the main program. In the main program it says move LW 0x01. That means 0x01 is moved to W register, which is the working register, and then it says NWF port B 0. That means this does inclusive AND operation of port B and what is in the W working register and set the result at the W register. So since now the value of the W register is 0x01, so 0x01 will be inclusively ANDing with port B. So if port B pin 0's value is 0, the result will be 0. If port B's 0th bit is 1, the result will be 1, and whatever the result will be stored in the W register. So if this was 1, this will store in the port B register, but since this is 0, it will store in W register. And then it says BZ LED off. So branch 0 to LED off label. So what does this branch 0 means? Branch 0 means if the result of the previous operation is 0, it branches off to LED off at this particular point, and if it is non-zero, it will continue through this. Now if it is non-zero, it will go to this label and then do move LW 0x01. That means again 1 will be stored in the W register, and move WF port B. That means what is in W is set to port D register. So port D will be set to 0x01. That means the 0th bit of port D will set to high and go to main, means again it will be going back to main and continue. Now from BZ LED off, if the previous operations result is 0, it branches off to LED off. So if it branches off to LED off, then it says move LW 0x00. So if it is move LW 0x00, 0 will be set to the W register, and it says move WF port D. So what is in W will be set to port D. So now port D will be set to 0 because what is in W is 0 now. And then it will go to main. So that means it will go back to main. So it will either go through this path and come to the main, or it will go through this path, come here and go to main. Right. So I will show you this operation using a Proteus simulation.